Hello students, this is the World of Chemistry, Dr. Vikram Panchal, and the topic is chemical kinetics. In this lecture series, this is lecture number 3. In previous lectures, I discussed about the rate of reactions, which is very important. Rate of reaction means how much time required to complete the reaction, or how much time required to complete particular amount of reaction. That is very important, even industrial viewpoint. Why? Because uh, in industry the most important factor is time, because it is related to financial things also. So that is why rate is very important, and this information is obtained from chemical kinetics. Okay, in this lecture I'll discuss about the law of mass actions and Lust-Ateliers principle. So let us start with law of mass action. Law of mass action, this was given by two Norwegian scientists, Kullberg and Waage, in 1864. Okay, but this is very important law. The law says that the driving force of reaction is proportional to the product of active masses of reactants. Well, this law is very simple as such, but doesn't look like that. Why? Because there are typical words used for different things, like driving force. This driving force means rate of reaction. Okay, rate means driving force. Sorry. Then second word, which is very typical, is product. Here product means multiplication. And active masses, this is also very typical word, active masses, and it means concentration. So now it is easy to understand what does it mean. It says that the rate of reaction is directly proportional to the multiplication of concentration of reactants. So this is the interpretation of this reaction. Now let us put one chemical reaction. Okay, so you can understand. A simple common reaction is AA plus BB reversible gives CC plus DD. It is very commonly used equation where capital A, B, C and D are reactants and products simultaneously, and small a, b, c, d are moles or coefficient constants of the reactants and products. Okay, so this is a common reaction. Now according to law of mass action, we can interpret this equation like this. Here we consider Vf as rate of forward reaction and Vr will be rate of reverse reaction. So rate of forward reaction, for that the reactants are A and B respectively, so is directly proportional to concentrations of reactants, that is A and B, and product means multiplication of the concentrations, and small a and b are moles of A and B respectively, so that will go into the power. So A raised to A B raised to E. So VF is directly proportional to A raised to A into B raised to B according to law of mass action. So now if you want to put equal sign, we need constant. So we write K, Kf, that is constant, proportionality constant. And that is, so VF is equal to Kf into A raised to A and B raised to B according to law of mass action. Now, for reverse reaction, C and D will be reactants and A and B are products. So for reverse reaction, we write according to law of mass action, VR is directly proportional to C is concentration of product C raised to C, moles of C, and concentration of D raised to D, and multiplication of these two concentrations, that is active masses. Okay, so product of active masses matlab C raised to C and D raised to D. Okay, so if you put equal sign, then we need VR is equal to another constant, proportionality constant, KR, that is KR. So VR is equal to C raised KR into C raised to C and D raised to D. Okay, so this way, according to law of mass action, for forward reaction, we write VF is equal to KF into A raised to A, B raised to B, and VR is equal to KR, C raised to C, and D raised to D. And if you know very well, then at equilibrium, VF is equal to VR, and if we compare these two, then we will get a final equation of equilibrium constant K equilibrium is equal to C raised to C, D raised to D upon A raised to A and B raised to B. Okay, I think you must have studied this in equilibrium, chemical equilibrium chapter, and it is very simple. We have to compare these two, and when we equate these two, Kr upon Kf become equilibrium constant K equilibrium, and for that we write concentration of products upon concentration of reactants. Okay, so this is regarding law of mass action. Now we will see another part of equilibrium state, which you have studied very well, and that is Le Chatelier's principle. The Le Chatelier's principle is related to the equilibrium state. It says that at equilibrium, if you change any external factor like temperature, concentration, or pressure, there will be change in equilibrium state. Okay, and change is according to the change in external factor. Sorry. So let us know Le Chatelier's principle. A change in any of the factors, external factor, that is concentration, pressure, or temperature. So that determines the equilibrium conditions of a system. Will cause the system to change in such a manner so as to reduce or to counteract the effect of change. Well, this is theoretical definition. If you want to make it more simple, it's very easy. In fact, it's very simple thing. Like if at equilibrium, you know that rate of forward and reverse reactions are equal, even concentrations are equal, and sorry, concentrations are constant, temperature is constant, pressure is constant. Now at equilibrium, if you change any of this factor, concentration, temperature or pressure, then there will be change in the equilibrium state. And the change is according to the change which we did. Okay. For example, effect of change in concentration. That is on addition of reactant. At equilibrium, if you add reactant, then what happens? Then the change is the rate of forward reaction increases. This is the change. Next, on addition of product, what would happen? When you add product at equilibrium, then the rate of reverse reaction increases. So this is the effect. According to Le principle, this is the effect. Similarly, on removal of product, what happened? Well, if you remove product at equilibrium, then rate of forward reaction increases. Rate of forward reaction increases means concentration of products increases. And on removal of reactant, what happened? Then we can say that rate of reverse reaction increases. And if rate of reverse reaction increases, that means the concentration of reactant increases and concentration of product decreases. So this is the effect of change in concentration. Okay, so this way we can have effect of temperature as well as effect of pressure change. At present, our intention is to study chemical kinetics, and in that case concentration of reactant change is very important. So that is it in this lecture. Thank you.